Ο τελευταίος λοιπόν ομιλητής μας για σήμερα είναι ο κύριος Φλουρέντσου, να με συγχωρεί. Είναι κυπριακής καταγωγής. Τα τελευταία 20 χρόνια ζει και δραστηριοποιείται στην Ελβετία σαν φυσικός κτηρίου. Έχει συμμετάσχει σε πολλά ερευνητικά προγράμματα τα τελευταία 8 χρόνια μέσω της συμμετοχής του στο Ομοσπονδιακό Ινστιτούτο Τεχνολογίας της Λοζάνης και θα μας πει ένα θέμα, νομίζω ότι πρέπει για να μας δροσίσει πριν την τελευταία μας συμμετοχή στο στρογγυλό τραπέζι. Του δίνω το λόγο, ευχαριστώ πολύ.
Καλησπέρα. I still hesitate if I speak in approximate English or in approximate Greek. My last speak in Greek, I did it when I was in the 5th class of the secondary school. I don't know if I managed to do it, as there are not so many English-speaking people. I will try to speak in Greek. Συγγνώμη για τα ελληνικά μου, έχει πολλά χρόνια που είμαι στο εξωτερικό.
Forgive me for my Greek. I've been abroad for years on end, so I will try to improve my Greek. Nonetheless, I will discuss natural ventilation and cooling techniques.
Town Hall. Μόνος μου δεν θα μπορούσα να σας μιλήσω για αυτό το κτίριο αν δεν ήταν ένας αρχιτέκτονας πίσω για να ακούει ένα φυσικό, αν δεν ήταν μηχανολόγοι πίσω για να ακούν τις ανάγκες και να μπορούσαν να προσφέρουν τις τεχνικές λύσεις. Είναι μια συλλογική δουλειά. Μιλήσαμε για passive buildings. Έτσι για να καταλαβαίνετε τα μεγέθη, ένα passive house στην Ελβετία είναι 30 κιλοβατόρες ανά τετραγωνικό και εγκαταστήνουμε 10 βάτα ανά τετραγωνικό μέτρο για τη θέρμανση. Ένα διαμέρισμα 200 τετραγωνικά θέλει 2 κιλοβάτ θέρμανση εγκατεστημένη. Δηλαδή μπορείτε να θερμαίνετε το σπίτι σας όταν ο Λέβιτας, δεν έχει Λέβιτα φυσικά, αλλά πες όταν το heating system χαλάσει, με ένα πώς το λέμε, πιστολάκι του μαλλιών μπορείτε να θερμαίνετε μια κατοικία. Αυτό είναι το passive house. Μιλούμε για άλλο πράγμα, δεν μιλούμε για τα ίδια κτίρια που γνωρίζουμε. Και οι αρχιτέκτονες και οι μηχανικοί μιλούμε ότι θα έχουν τεχνικές απαντήσεις για άλλο πράγμα από αυτό που ξέραμε. Λοιπόν, είναι άγνωστο, όταν είναι άγνωστα πρέπει να τα κάνουμε, να τα προσομοιώνουμε, θέλει γνώση. Θα μιλήσουμε για passive cooling, δηλαδή δωρεάν cooling. Αν ήταν δωρεάν θα τρέχαν όλοι να πάρουν. Λοιπόν, δεν είναι δωρεάν, χρειάζεται γνώση. Και επειδή η γνώση θέλει κόπο, θέλει κούραση, θέλει μελέτη, δεν πάει κανένας να τα πάρει τα δωρεάν και προτιμούν να πληρώνουμε πετρέλαια, να πληρώνουμε μηχανήματα. Είναι όμως δυνατόν, θα σας δείξω ένα κτίριο που την πρώτη φάση ήδη...
Well, I'll show you a building. Stage 1 is already up and running. This is the town hall of Nicosia.
Πολιτικοί, ξέρω εγώ, να κάνουν θεμέλιο λίθο.
Were there, they inaugurated the building, they laid the foundation stone, and so they bumped into an ancient church. It seems that there were 3 layers of antiquities there, a medieval town, a Byzantine one, a Hellenistic one below that, so it took 8 years archaeologists to clean up the surface area. And so here you have it.
Ευτυχώς η UNESCO, ευτυχώς για το Δημαρχείο δηλαδή, η UNESCO έχει πει ότι απαγορεύεται να κάνουμε εξκαύση σε όλο το χώρο, πρέπει να είναι υποπέδου για τις επόμενες γενιές, διότι θα έχουν καινούργιες
It's imperative that we leave at least 1/3 of the plot to the next generations, because the next generations of archaeologists will come up with new ways to proceed with exploration. And so they instead architects could have built something on top, or they could have built columns and pillars. So they found a plot of land which was adjacent, and this led to, well, this is the so-called green line in Nicosia. So you see, instead of starting with, or rather, instead of having one plot of land, a whole neighborhood was impacted, and they tried to make sure that this was a lively place. This is an eco neighborhood. I was in touch with the architect. I would tell him about the guidelines and the principles, and he would make plans. I'd tell him what's operating and what's not. So this is what we got. We have the square, which allows for passive cooling. And moreover, it allows for visitors to look at the antiquities as well. This is a simulation. This is a building that is almost complete by now. And the building will look like this. We will have 3 buildings for offices, one for the so-called municipal hall or city hall meeting premises, because it has to be light and the antiquities are below. We also have the shadowy areas. We tried to have green areas and spaces. We didn't just want to have natural cooling, but we also wanted to have good conditions on the outside. This is the part of the construction that is already there. Let's have a look at the figures. If the building was constructed back at the time when there was no thermal insulation and no relevant regulation, it would have needed 200 kilowatts per hour per square meter for ventilation, for heating and cooling. And then we had the regulation, which has just been ushered in. You've had such regulations for years in Greece, but it's new for us. If you have 4 centimeters of insulation and 3.5 for glazing, that's the U value, you can diminish the cost by half. So we solved one problem. But then again, the problem became quite more acute because single-pane windows have no losses now. And so in our case, we're going to go below 40 kilowatts per hour. Minergy calls for 40 kilowatts per hour primary energy. And so, the buildings, before the energy regulation came, were consuming a lot of energy for heating and cooling purposes. This applies to Athens, given the photos we've seen. And even if you don't have thermal bridges, if you have some sort of insulation, things improve. And the new city hall of Nicosia is going to bring consumption down by 1/4, or rather divide by 4 consumption. And this is season 2 for carbohydrates. Hydrocarbons, rather. We have consumed half of the oil that's on this earth. In this second stage, we will have to pay a higher price for oil. And so, we will have to make the relevant calculations. I have a 30-watt computer there for one company to be able to sell that, and for it to have 5 hours of standing battery, it's, well, changed that, so you have to divide by 10. When there is a need, there's technology. Now, where can you get hold of this technology? In every house, unlike computers that are produced in plants, in every house you have architects and engineers who have to make leaps and bounds technology-wise. We use 10 passive techniques in this building. 10 centimeters thermal insulation, double glazing, low E, and no thermal bridges. Moreover, we have almost perfect solar shading. We also had high apparent thermal mass, optimum dimensioning of openings for passive lighting, 70% of natural light autonomy and high efficiency artificial lighting. Well, you see, if you don't have thermal mass, you know what the impact will be, or we will discuss it later. The dimensions of the openings need to be optimal. We have to find trade-offs. For lighting, heating, and solar protection. Every use and every space has different needs. Mr. Papadanil, of course, used a rule. He said we will all have no openings in the north. Please don't use it in your offices. Your rule, Mr. Papadanil, applies to residences, but it doesn't apply to office spaces here in the Mediterranean. It works in Switzerland, but not here. And then you have 70% natural light autonomy, like I said, and high efficiency artificial lighting. We can't have conventional lamps and air conditioning working in one place. Maybe in Switzerland that would be okay because it contributes to heating the area. But in this case, in this part of the world, it wouldn't work. 30% of the surface area is outside of the thermal envelope. And this, of course, wouldn't work in Switzerland. But you see, 70%, or rather, we in Cyprus have sunshine for almost 300 days a year. We can actually go outside and have a picnic in Christmas time, for that matter. So we have different needs. Opening design for optimal night ventilation, summer passive cooling, natural ventilation, and use of ceiling fans. Maybe ceiling fans will seem to you as quite an obsolete technique. But let's see what they can do to a passive building. And then you have 100% solar hot water. When you get sunshine for 300 days a year, you are not going to use electrical power. This bioclimatic building does not use sun-passive techniques. Okay, we've seen such buildings. We have a well, we have a louver, we have a channel, and you can get the air in. These are some scattered pieces and bits of ideas. The Swiss have a lot of good things to suggest, and they also have a few bad things to suggest, and this goes to Cyprus as well. It applies to us. One good thing I borrowed from the Swiss is that they say one thing, they do that thing, they see how it works out or not, and then they try to improve. They make measurements. How much is consumption? Primary energy, 38 kilowatts per hour. Okay, this is bioclimatic, but as long as it pays out, as long as it gets results. This is what we did in the case of this building. This is not one simple building that will be comfortable. My grandmother's house was actually bioclimatic, but its energy consumption was zero. Then again, it didn't have 500 lux that was self-standing for you to work in your office. And then in my grandmother's house, the temperature was good because the outside temperature was 45, and then within the house, the temperature was 32 degrees. Minergy is something that you heard about this morning. Let me start with thermal insulation. We went from 4 centimeters to 10 centimeters. And there's more to it than that. Oh, thermal bridges. were taken into account, and we opted out of thermal bridges. We didn't use thermal insulation on the ground. You see, on average, temperature in the summer is 20 degrees, but we needed thermal insulation at the base of the building because without thermal insulation, you would get the cold in your feet. So we have thermal insulation there. U value is 1.3. The glass panes were made in Cyprus, 1.3 U value. You don't have to import them. No, you don't have to buy them from Germany. No such need. So from the reference building of Cyprus, we got down to 8 kilowatts per hour, which is next to nothing. I mean, your hairdryer would need more. This worked for 1 year. It was actually constructed, it was built last year. I went there in the summer. They told me that it worked okay, better than the simulation tests. They told me that they would just hit the building for a quarter of an hour and it would do for the rest of the day. Reinforced thermal insulation. We divided everything by 1.6. But then we are dealing with the cooling pod. And let's see what we did with that. The first thing you need to do when you have water that is coming in, you're not just going to find a pump, you have to somehow find a way to block the entrance of the water. You have to find a way that would not be that costly. So it didn't cost that much in this particular case. We had almost perfect solar shading. Orientation helped us. So in this case, we had a building that was oriented towards north-south, north-east-west, and we didn't need special systems. We just changed the dimensions of the openings. We were facing the north by 15 degrees. So once in Switzerland, I was faced with the same angle and said, no shading is needed. And then this was about an office space where the offices were really sunny. I made amends in this case. We introduced those films, and as you can see, we are almost catered for thanks to them, and G value was for the panes 0.4. So that after simulations turned out to be quite effective. This building was a cause of headache for us. It was 10 meters high, full of glass panes. It is. And this is facing the west, so we thought maybe we should have one shadowed or shaded square there, an opening that would solve everything here. So this is an ideal building to explain to students about how you should properly orient the building. You should have the office spaces in the north because you want to avoid cooling problems, not heating. Heating is not a major issue. And then you have to take into account the importance of lighting. 20 kilowatts per hour is a lot of energy. It's as much as an energy building will need to heat itself. And so I would look into possible sources for natural lighting from the north. And thus all the offices are looking towards the north, and then you have the facade treatment here. The west is always the toughest in our climates. There is no office space there, it's just the stairwell and open areas. And then this part of the building. I'll show you the in-out as well. You have a small building there. It was built so as for the users to house all their polluting activities there, to avoid need for ventilation. And the water closets are also outside the confines of the air-conditioned area. So you have one eastern facade there, which is shaded, and then you have this opening for facades, and there is a shelter on top to solve all the problems that pertain to all four facades. Effect of solar protection: no solar shading, 60 kilowatts per hour per square meter. Solar shading with 39% of glazing. You see, we brought kilowatts per hour per square meter down considerably, and then we had solar shading, glazing, 39%, and internal blinds. And this helps save money by 37%. Most of the buildings in Cyprus and Greece have external solar protection. It is important to have such protection, and it's compulsory in Switzerland. You can't have air conditioning installed otherwise. So we started putting in place, or rather we started aligning ourselves with the regulations that we got from the north, from the EU, and we failed to introduce yet another regulation on shading and solar protection. Hopefully your Greek regulation has that. We don't in Cyprus. Apparent thermal mass. We used ecological, eco-friendly gypsum, which would give us proper protection. So 4 centimeters will level out the floor. So we have the floor and the ceiling. And this is where we will store heat in the winter and unwanted heat in the summer. It is very important in our thermal mass matters a lot in our climates. If we discuss Minaji in the south, then thermal mass will have to be one of the criteria to take into account. Here you have simulation. Thermal mass, no thermal mass. Of course, when the air conditioning unit is used, there's no great difference, although at night time the light buildings will go up, but you see in the summer you get 37 degrees instead of 30. This is part of the simulation. I measured these myself. I was there in September, and I got, never did I get over 30 degrees when outside it was 46%. Opening dimensioning, we said we have to strike a balance between the light coming from the sun, and we don't have to exaggerate anything, so we have to strike the perfect balance. In this case, we used a panel 140 times 300 for each office, and we also used 2 panels facing the south. They are open so as for us to make sure we have light in. Natural lighting, 60 to 85% autonomy. We didn't use anidolic elements, but they are still being looked into. The good thing is that in Cyprus we have lots of light. We don't really use such elements, but at least we found out, we knew where we get light in from and where we get the air from. And so we didn't have frames, we got lots and lots of light, so that got us the autonomy I referred to, 60 to 85%. All the walls outside and inside were painted white, and so we managed to have good performance. People who measured, or rather people there told me they never used artificial lighting. It turns out that all public servants in Cyprus go home early. Inside, outside, in the Mediterranean climate, our weather is good. So why should we have air-conditioned water closets? Why should we have smoking areas that are being air-conditioned? This is the smoking area. It's not air-conditioned. Stairwells are not air-conditioned either. We didn't start bioclimatic designs per se. We started with a questionnaire. We asked people what would make them feel comfortable, thermally speaking. And 90% of the people who answered to our questionnaire said they want something that's natural. I keep getting this air conditioning in the air. It's actually pestering me. It's a pain. No, unlike that system, we opted for different solutions. So they filled in the questionnaire. They said that they wanted a smoking area. They wanted an area where they would have coffee. That's why everything is outside. And then I guess they don't have to pay taxes or penalties for the fact that they are actually... This is a public service. When at the end of January people will come to pay their taxes, they will be able to be outside and they can smoke freely. This is actually a monumental staircase, right? One that is the dream and very vision of every architect. And in this case, I'm not going to discuss ecology in this particular case, but you see this wood is actually unglazed, it's natural, we didn't paint it. We used oil, so you can actually lick it if you want to. It's pretty natural. So, we left 25% of the surface area outside the air conditioning system, so insulation is less. Night ventilation design. It's not enough for you to just punch in, I need night ventilation, and then your simulation program will get you the solutions. It's important to have proper design. You have to leave scope to people, leave people scope with opening the windows. You see, this is the building where the treasury of the municipality is, so all the money of the municipality is there. The financial department of the municipality's house there, so you have to let people open a window sometimes. So have a look at the photo. We want to have stack effect. To have the stack effect, you have to have height. This is 3 meters high. But if you open one big window, you will have lots and lots of air coming in winter and the summer, so it's going to be very, very hot then. What did we do? We had the night cooling. We also had this divided in two, and so you can have a smaller opening when the weather outside is bad. In Switzerland, they have the heat recovery units instead. In Cyprus, heat recovery will not actually be worth its money. In Cyprus, we have a very small temperature difference, and so the electricity you're going to spend is going to be more than what you will win or save. So we tried all possible combinations in their openings, where we're going to have the halfway, have it tilted, have a louver, or we tried everything. So as for the employee who's there to intuitively act and get 30 cubic meters or 10 liters per second. I don't know what the metric unit you would use in Greece would be, but you can use up to or save up to 366. So the employee will just tilt the window when they get into the office. It's true that many of us suggest that we do not trust the user. It depends on what you give the user. When the planning, when the design is in favor of the user, when the design is such that will make the user tilt it intuitively, then it's going to work both in the summertime and the winter. When it's 45 degrees outside, no one will intuitively open the window to get the heat wave inside the office. And when it's actually breezy outside, nobody will intuitively open the window. Effect of night cooling. In Switzerland, if you want to cut down on the kilowatts per hour per square meter, you will introduce a heat recovery unit. In this case, you will just open the window at night, and you have to have thermal mass in there to store the energy. So you see the statistics without night cooling, 43 kilowatts per hour. Night cooling would get you to 38. If this was a metal construction and there was a false ceiling as well, and with our option we managed to go from 36 to 17 kilowatts per hour per square meter. So you have half of what you originally had. In our climate, it's unlike Switzerland. You have passive heating in Switzerland, and here in Greece and in Cyprus you have to do something about winning something thanks to the cooling temperatures of the nighttime, without letting robbers in, without letting particles in, without letting dust settle. A light building has only 25% of reduction potential. This is exactly why we bothered to find materials with thermal mass. Ceiling fans, people kept them especially in the mom-and-pop stores because that made sense. I remember whenever I went to the small stores, there were ceiling fans, and now they're back. They're back because instead of having users open the windows and letting subsequently warm air in the room, ceiling fans work because they're trapping the cool air. When the temperature is 30 degrees and you have a ceiling fan going, you feel like it's 27 degrees, but the building temperature will rise, and as temperature rises, the outside, I guess, temperature will be 33 and the building's temperature will be 30 instead. My feeling will be 27, so you have a trap. You shouldn't let the user fall in that trap intuitively, which is why we have offered them the option of having tilted windows instead. And it turns out, I've seen it this year in Cyprus, people opt for having their windows tilted instead, and they use their ceiling fans. People this year, as I noticed, set the air conditioning unit at 28 degrees and not 23 or 24. They thought about it themselves. We never told them. There was a user's manual. We started with the questions and the questionnaires, and we drafted eventually a user's manual last week. We told them about the ideal temperature, and they turned out to be proud because they told us we thought about it before you came with the manual. We knew how to change the set temperature, and so we turned our temperature. Of course, all the measurements were not made on the basis of Ménager. I mean, ceiling fans is not something that we explain to the Swiss, but we followed the conventional lines, and using the conventional means, we managed to save kilowatts per hour per square meter. Such a building calls for a study or design for 30 or 50 days, but it's worth the money because buying equipment instead will cost more. Need of correct cooling load dimensioning. You cannot make a comparison between this building and buildings you know. This is the statistics for 50 square meters, and you have the maximum of 250 without night cooling. This is the load, so it's 50 watts per square meter when it's 45 degrees outside. When When you overdimension, good, I'm picking up new words in Greek now, says the speaker, you pay more. We paid 10,000 euros on top to buy a state-of-the-art equipment, which would give us 5 COP at 70%. When you are good in terms of dimensioning, you will get 5, which means 1 will generate 5. But in Cyprus, we want to use everything in excess. And so we do. Normally, we exaggerate. So you will get stuck there at 2.5. Engineers wouldn't dare go that low because architects will go, and then the users will pick a fight with the mechanical engineer. When what Kostas happens, when what Kostas said happens, when everybody works as a team, architects and engineers will work together, and the architect will not just be the salesperson of, say, a piece of equipment. The architect will be both a salesperson and someone who will work with the engineer, and the engineer will not be selling either. They will spend hours making calculations too. And this is what happened in the case of the people who designed this building and the people who constructed it, for that matter. Monitoring outside, so the Swiss will tell us this is like that and do it. So this is what we did. We measured 45 degrees Celsius outside, and it was 30 degrees inside. I was fortunate enough to be in a cooled, occupied office. So half of the building was empty. The rest of it was occupied. In the case of the occupied office, you have the degrees there, temperature. At night time, there was no night cooling there because we hadn't told them to do so. We haven't explained. Then you have the simulated occupied office statistics and then the unoccupied office. So you have the office, the free-running office, if you will. It was 45 or 43 degrees outside, 30 inside. The concept works. I'm going to rush through the slides and photos. You have another 5 minutes, there's a chair. Right. So let me show you. A couple of photos. It just so happens that we have a Minergie building in Geneva and another one which is still Minergie in Nicosia. In this case, we had big openings in the south, and in this case, we had small openings to the south because we just wanted to confine our passive heating needs. In this case, the opening, or rather, the north is glazed by 70% because we needed to have light. These are the facades, south facade for the building in Geneva, and then you have the north facade of both buildings. We are going to have our own passive cooling building. This is how it's going to work. This is the Swiss statistics, Swiss climate, 21 to 19. And the outside temperature may be -10 or up to 5 or even 7. When they get a night, January break, sunny break, it's 7 degrees, and that's good. Now, Cyprus, climate in Cyprus, at daytime, especially during the working hours and weekdays, normally you get more than 15 or over 21 degrees on occasion, and you get the sunlight in. It's striking you and it's hitting you. So you see, the buildings work in a different way. And in the summertime in Switzerland, you will get a couple of times when the temperature will exceed 27 degrees. You will need 3 kilowatts per hour per square meter for cooling purposes and 56 for heating purposes. And in Cyprus, it's 8 for cooling and 36 for heating. So it was cooling and heating respectively. Just as long as you have a good building, not the old ones. In Geneva, you need passive cooling, you need solar heating and ventilation control. In Nicosia, you need solar protection and passive cooling. So these are the statistics for July. In Nicosia, where the climate is dry, at night the temperature may be 18 or 22. Maybe it will get up to 28 degrees 5 days a year. So this is what you get on average. This is a so-called natural system that you're called upon to optimize, and this is unlike the respective systems in Switzerland, almost zero energy office building. Let me sum up. We did not study residential buildings. This is about office buildings. We need good thermal envelope and reasonable solar gains, perfect solar shading and reduction of internal gains, natural light, controlled natural ventilation and natural cooling, as well as high-performance cooling systems. Renewable energy is down the bottom of my list. It's actually the cherry on your cake. People claim that one roof with PV will work and it will be almost zero-energy building. No, this is not true. So photovoltaic will not just turn your building into a bioclimatic one. These buildings have some PV photovoltaic panels on top and maybe geothermal to some extent. In this case, we didn't have solar cells. We thought, okay, let's consume 15 kilowatts per square meter. I made the measurements. Consumption is 50 kilowatts per hour per square meter, including everything. The building uses energy mostly for the server. So we didn't use solar panels. When all Nicosia will be passive and all the industrial areas will be full of solar panels, then okay, let's change the character of the center of Lefkosia, of Nicosia, and let's have solar panels there. Until 2050, when we're going to get down to 2 kilowatts per hour per square meter, fine. In the meantime, we put on top of the building an open-air meeting room, because we also think we can save energy from up there instead of having people with beamer. So instead of having them inside the building, we have a green roof, we have shading, and so they have a meeting room there, they can convene, and I think it works better for them and for us. Thank you very much.
Ευχαριστούμε και εμείς πολύ τον κύριο Φλουρέντσου. Νομίζω ήταν ό,τι καλύτερο για τις ομιλίες για να τελειώσουμε έτσι και με μια πιο ευχάριστη διάθεση. Θα ήθελα να παρακαλέσω να μείνετε όλοι στο στρογγυλό τραπέζι που θα ακολουθήσει, γιατί πιστεύω θα είναι πολύ ενδιαφέρον. Θα ήθελα να σας υπενθυμίσω ότι υπάρχει άσρε και πάντα σας θέλουμε να γίνετε μέλη και να συνδράμετε ενεργά και στις συμμετοχές του ελληνικού παρατρήματος, αλλά και γενικότερα στη διεθνή δραστηριότητα της άσρε. Και επίσης, οφείλουμε ένα πολύ μεγάλο ευχαριστώ στην κυρία Γεωργία Τσιλίκη, τη μεταφράστριά μας στη μεγάλη αίθουσα εδώ, που προσέφερε αφιλοκερδώς τις υπηρεσίες της. Την ευχαριστούμε πολύ. Μας βλέπει από μέσα. Θα δώσω τώρα το λόγο στον κύριο Παπαδανιήλ. Θα καλέσω και τον Κώστα τον Παλαρά στο πάνελ για να ακολουθήσει το στρογγυλό τραπέζι. Ευχαριστώ πολύ.